Hello, statisticians. Today's lesson is about box plots and resistance. Let's get started. Imagine that a boss is recruiting you to work at their company, and they tell you that the typical salary at our company is more than $65,000 per year. Now, that sounds pretty good, but the devil is in the details, and sometimes recruitment statements like this might reflect a little bit of misleading information. So this brings us to our key question. When you hear a statement like this, how can you use the tools of statistics to figure out how much money might you really make? With that question in mind, let's move into our notes. We're going to discuss 4 topics today, starting with 5 number summaries. Let's look at these principles when applied to the data set for this lesson. Salaries at Star Builders Marketing, where the boss is trying to recruit you for this new role. It's a small company with 13 employees, and each of their salaries in thousands of US dollars or USD is shown here. So, because the scale is in thousands of dollars, the 38 represents an employee that makes $38,000. The 55 represents an employee that makes $55,000, and the 164, well, that's the boss. They make $164,000 annually. These values also happen to represent the minimum, the median, and the maximum salaries in our data set. And next, we're going to add in the quartiles. Q1 is the $46,000 that one employee makes, and Q3 is the employee that makes $76,000 per year. These numbers together are what we call the 5-number summary. These give us an overall sense of the scale and variation in this data set. Next, we're going to move on to outliers, and we want to figure out, are there any outliers in this data set? There are 3 ways to determine if there are outliers. The first way is to just kind of look at the data set and look at whether or not there appear to be any numbers that are unusually small or unusually large. And you can start by creating some sort of visual and just eyeball it. It's pretty intuitive. Now, obviously, this isn't very scientific, but it's a pretty good place to start using your gut instincts and seeing if you see any large gaps in the data. That's a good place to start. So here we have a dot plot of our salaries, and we can see one dot all by its lonesome over on the right. That is the boss's salary, and it seems like it could be a potential outlier. We're going to follow that up with some calculations, and we're going to calculate what we would call a lower bound and an upper bound, and any numbers that are below the lower bound or above the upper bound will be considered outliers. We said there were 3 methods for finding outliers. This next one here is called the IQR method, and it's a calculation. We're going to start by finding the IQR, multiply the IQR by 1.5, and then define the lower bound. We'll do the first quartile minus 1.5 times the IQR, or the third quartile plus 1.5 times the IQR, and that gives us a set of bounds. Any numbers outside of those bounds are considered to be outliers. So let's take a look at our data set. We already have Q1 and Q3. We're going to find the IQR by subtracting them, and that gives us a value of 30. Remember, that's actually $30,000. So our IQR is 30 or $30,000. Multiply that by 1.5 and subtract that value from 46 to get our lower bound of 1. That's really $1,000. So any employee that would make less than $1,000 per year would be a low outlier. Our lowest value is $38,000. So we don't have any employees that are low outliers in terms of salary. Next, we're going to move on to the upper bound. So we're going to do that same calculation again, but with the Q3 plus 1.5 times the IQR, we're going to get 121, which is really $121,000, remember. So any employee that makes more than $121,000 per year is an employee whose salary is a high outlier. And it turns out that our boss, he is someone that gets a salary that is considered to be a high outlier. So our intuition when we were eyeballing it earlier, that was correct. He is an outlier. Now we're moving on. Now that we know our 5-number summary and we know how to find outliers, we're ready to make a box plot. So a box plot is a way to visualize the 5-number summary. Specifically, we're going to take these 5 values and our outliers, and we're going to turn it into a box plot that looks like this. And you can see actually those 5 numbers on this box plot. Here they are. So first, we'll notice that outliers show up as individual points. If we had more than one outlier, we'd have more than one of these individual points like this. If we had no outliers, we wouldn't have any lonesome points on the number line like this. Next, we have the box in the middle. The box has 3 vertical lines on it, and those are the quartiles. Next, we have the whiskers coming out of the sides of the box, and those go to the min and the max in general. If there are outliers, they go to the number that is not an outlier. So little question mark here, 95, that's not actually the max. It is the largest number that is not an outlier. Now, next interesting piece of information, remember we said quartiles contain 25% of the data. So between Q1 and the minimum, that's 25%. Between Q1 and the median, that's another 25%. And between any 2 consecutive quartiles, that is, you guessed it, 25% of the data. If you have 2 quartiles next to each other, so Q1, Q2, and Q3 together, that would be 50% of the data. If you've got 3 of them in a row, from the min to Q1 to the median to Q3, that's 75% of the data. This will come in handy. You'll see some questions related to what percentage of the data are between these values. Definitely keep this in mind. All of these things will come in handy. Now, this is a little interesting. Look how lopsided that looks. That is going to help us determine shape. So we're going to bring back our dot plot, and these 2 things together, you can kind of see some interesting things going on here. You can see, as we saw earlier in the course, the right skew here. And now that we're looking at a box plot, you can also see the right skew there because you've got so much of the data compacted tightly in the box. You've got 75% of the data between Q1 and Q3, and it's all tightly bound together on the left part of that graph. And then the right side is very spread out. That's showing you that long tail, and you can still see it there in the box plot. So in a box plot, you cannot see whether the distribution is uniform, unimodal, bimodal, but you can see whether it is symmetric or skewed right or skewed left, based on whether the whisker or the side of the box is longer. So you can see that part of the shape there. So if we go back to our salaries and we wanted to describe the distribution, just like we described histograms earlier in the course, we can do that. Remember, we start with the big picture, start to zoom in closer, and then finally look at the details. So remember that strategy. A description might look something like this. So the box plot shows data that was collected on salaries. Start with our context. Then we move to shape and center. It is skewed to the right with one outlier above $160,000. The median is about $55,000, and the IQR is approximately $30,000. That's a pretty good description of the distribution from the box plot. Now, last idea here. Let's talk about resistance. Let's return to the statement we mentioned at the beginning of the lesson. The boss at Star Builders Marketing, whose salaries we've been analyzing throughout this lesson, they're trying to hire you. And they said, although new employees start at a salary of $38,000, there is room for advancement. The typical salary at our company is $65.5 thousand. Recall that that is an okay statement. The mean was $65.5 thousand. But maybe it is not typical. Let's figure that out. Is it really typical? So let's look at that in this interval of data. 65.5 falls right here in the distribution. And that number is higher than 10 out of 13 of the employees, higher than 77% of the employees, more than 3/4 of them. So saying that that number is typical when it's more than the vast majority of the employees' salaries, I'm not sure about that. I think that is BS, bad statistics. What if we don't use the mean, but instead we use the median right in the middle, $55,000? That might be a more representative measure of center. So what exactly is going on here? Why is the mean no longer a good measure of center, but the median is? Let's look at a hypothetical here. Let's imagine that 1 year ago, the boss used to make $100,000, and then they decided to give themselves a raise to $164,000. So previously, before the raise, the mean salary for the entire company was $60.5 thousand and the median was $55,000. Now, after the raise, the new mean was $65.5 thousand and the median was $55,000. With the boss's raise, we can see that the mean changed. Specifically, it increased by about $5,000. However, the median didn't change. It stayed $55,000. Now, we can also look at measures of spread. We can see that the range and the standard deviation each grew when the boss gave themselves a raise. But the IQR did not change. This trait, where the median and the IQR don't change very much, or in this case stay the same, that is called resistance. The median and the IQR are resistant or robust measures of center and spread. They don't change much when you add in outliers. And in general, when you're working with a data set with outliers or a heavy skew, it is often better to work with median and IQR because they are resistant to change. When you have mean, range, and standard deviation, they are non-resistant, and they are more likely to change and be influenced by outliers and strong skew. Let's take a look at this visually. So when we have a distribution that is fairly symmetric, the mean and the median will be approximately equal to each other. When we add a right skew to the distribution or an outlier that is large, that means that the mean will be affected by that outlier or that skew, and it will get pulled toward those higher values. It will increase, and the mean will be larger than the median. On the flip side, if your distribution is skewed to the left, or you have a very low outlier, a small number, the mean will get pulled toward those low values because it is not resistant. And that will be reflected in showing that the mean will be smaller than the median. So now that brings us back to our discussion. We saw that the salary distribution at Star Builders was skewed to the right. Do you think this is usual? What do you think is the shape of salary distributions at other companies? Do you think that both small companies like this one and also large companies with many employees would look like this? What statistic do you think should you have about conversations and salaries when you're applying for a job? Take a moment to jot down your initial thoughts to these questions, and we'll discuss them further in class. That's it for today, statisticians. See you next time.